Okay. All right. Now, that was you understood. Now you should understand this. Atoms are incredibly small. Atoms are almost all empty space, and atoms have three parts made of three things. Atoms are all made of protons, neutrons, and electrons. And the general shape of an atom, simplified, and people cuss this shape or they belittle it, but it's really not very, it's pretty accurate. You have protons, whoops, protons and neutrons in the nucleus in the center, all right? And whizzing around it, and it doesn't have to be a perfect circular shape. It could be kind of a dumbbell shape. It could be kind of a weird shape. Are electrons, all right? Well, they spin one there, and then in there. So these electrons are coming through, going do 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 do, and they're negative. Let me do it better. Even that I did there. They're negative, and this is positive. So you have a positive center, and now one of the things people have calculated: if these electrons ever stopped, what happens when you have a magnet, a positive and a negative magnet?
They wouldn't stick together.
They wouldn't stick together if they're positive and negative?
No, if the electrons stopped.
You don't think positive and negative stick together?
No, if the electrons stopped, then they wouldn't stick together, would they?
No, that's not true. If the electrons stopped, theoretically, the negative would and positive would go whap, and slam together real quick. Because if you have a positive end of a magnet and a positive end, they repel each other.
So it's like
and a negative and a positive stick together.
So it's like orbit.
So these have to orbit. Yeah, and there's a lot of analogies, like with the Earth and the Sun and all that. But the idea that these electrons are moving insanely fast. It takes the Earth 365 days to go around the Sun. It takes this electron 0.000000001 second to go around. It's made a bazillion trips around this nucleus in 1 second, which makes the atoms seem like solid balls. You can never stick your finger in here, or you can never intrude and get to the nucleus because this electron would hit you 1,000 times before you ever moved. So that is your atom. You got electrons on the outside, far away, way farther away than this picture shows, but I don't have a chalkboard that goes a mile. And they're negatively charged, moving very fast. These are positive charged. They're held together by an incredibly strong force. And the force is so strong, they call it the strong force. Yeah, the strong force. It holds these protons, neutrons, and actually the quarks together, but it gets so strong. All right? Now, that is what your atom basically is shaped like.
The electron orbit.
No one is quite sure what makes it orbit. It just seems to be the nature beast. That's a good question. It's energetic. Energy makes it move. You can get it moving faster. You can even get it to jump orbit. You can get an electron to go from here to jump over to here. And then when it falls back down, it'll release a little photon of energy, a little package of energy. And that's how a fluorescent light or a neon light works, by releasing energy. So these electrons aren't, and you asked earlier, are they in a specific order? Not really. They can kind of jump and they can move around a little bit. But I said, then you get into quantum mechanics.
Could an electron make a new orbit?
It's hard to say what's a new orbit because you're just kind of predicting where it might be at any one time. You can't really tell exactly where it is. You just it tends to spend more time maybe here. Sometime it'll be over here, and this is a three-dimensional thing. So sometimes it's here. It's not going to be out here very often. It's not going to be here very often. It tends to be this far away. There tends to be more stable patterns. All right? Now, that is your orbit. That's basically what an electron's like. That's what an atom is like. Now, here's what scientists did that is so wonderful. This is so fabulous and fantastic right now. Let me make sure I have enough time for you to fully appreciate it. Scientists have put together this thing called the periodic table. And what they've done is an atom with one proton, they call that atom number one. It's just hydrogen. An atom with 2 protons
Helium.
is helium. An atom with 3 protons,
Lithium.
lithium. An atom with 4 protons is beryllium. An atom with 5 protons, 6, 7, 8, 9, 10, 11, 12,
Oxygen is
13. Don't it,
Oxygen
shush.
is
No
eight.
wonder your teachers always say you have to be quiet and not answer questions.
Wait, oxygen is 8, right?
Oxygen's number 8. It has 8 protons. And I don't care. You know, you can always tell a teacher that it makes you memorize the periodic table. You don't have to. It's a tool. You don't have to memorize any of these things. You just have to know this. They go in order. 5, 6, 7, 8. Oxygen has 8. Carbon has 6 protons. Fluorine has 9. Neon. I don't care if you call it an atom number 10. You don't have to remember neon. Then you have sodium, which messes people up because it's Na.
Why?
Okay, why do some of these elements, why are they named H for hydrogen and L for lithium and B for beryllium and
'Cause they
Zn for gallium?
They all have to be different. It's because if you have H for hydrogen, you can't put H for helium again.
But why does sodium have Na? Why isn't it S?
A different language, maybe.
Absolutely correct. You English speakers are lucky. Most of the periodic table makes sense to you. Titanium's Ti, scandium is Sc, calcium Ca. But iron's old. That's a Latin word, ferrous. Gold has been around a long time.
Au.
Where's gold? Gold.
Au.
Au. Gold was around a long time before the English language. Zinc, that's pretty new. Carbon, new word. Neon, argon, Ar, krypton, Kr, xenon, radon. But there's the
What about
old
the
thing.
TL 81?
81.
Pink.
Oh, thallium? That's TL. No, thallium's new. Thallium, TL. Thallium, that's not bad. I mean, that's not too far of a off. Phosphorus. So, yeah, a lot of them were discovered and named by English-speaking people, and so they kind of have more representation on the periodic table. Cesium, but so you're lucky. If you speak English, chemistry is a tiny bit easier to get because these. But I'm not going to make anyone memorize anything. All you have to know is this, and this is what's beautiful. The periodic table is truly the cookbook, the organizational chart of the universe, at least of all matter on Earth. You take some hydrogen, you mix it with some oxygen, and you make some water. You take some carbon, you mix it with oxygen, you make some carbon dioxide. You take some oxygen and hydrogen and carbon, and you make some sugars, or you make some carbohydrates. By mixing these things together, you make stuff. And they go together in certain ratios, which is really neat. All right? Yes, what?
Why is hydrogen its own, like...
Color?
Yeah.
Yeah.
And very good. Well, we're going to show you that. I'm going to probably, maybe I'll have a few minutes to start. I'll start this. I'm trying to keep these videos less than 10 minutes, and I haven't done either one of them, because I want you to, I want to be able to download them and so forth easily. But hydrogen is weird. Every one of these elements are kind of grouped in the way they act. Now I'm going to show you this because we have to get to the drawing. All right? But, okay, chemistry lesson 3, here's the deal. Atoms are tiny. Atoms are mostly empty space. Atoms have protons and nucleus in the center, and whizzing around them, moving at incredible, unimaginably fast speeds, taking
Electrons.
insanely large laps around this nucleus in sort of the same pattern, but changing once in a while, are the electrons. Atoms have 3 parts. The periodic table organizes every atom and lists them in the simplest way imaginable, in the order of their protons. The protons make it what it is. If an atom has 1 proton, it's hydrogen. If it has 2 protons, it's helium. If it has 3 protons, it's lithium. And so on. If it has 79 protons, it's gold. 26 protons, it's iron. 22 protons, it's titanium. If you could add a proton to gold, you would make it into mercury. If you would take 3 away from lead, you turn it into gold. People try that. They call those the alchemists. If we could get,
It worked.
yeah,
Oh, Dad, what's the?
if we could take osmium, which is the densest element, we could add 3 to it, we would turn that into gold. What?
In movies, people squeeze coal hard and it turns into gold. How does that work?
You're wrong. In movies, people squeeze coal and turn it into a diamond.
Oh, a diamond, yeah.
Okay? I'll show you that in a wee bit.
Is diamond on the periodic table?
No, because diamond is
Mineral?
not pure carbon. Diamonds are nearly pure carbon, but they do have, it's carbon in a certain shape. The graphite in your lead, the pencil lead, which you have a lead pencil, go grab a pencil, is and diamond are exactly the same thing. They're mostly carbon atoms, but they're in a different shape. Diamond's in an isometric crystal system where they all are kind of in a, like a four, stuck to 4 others in a shape like this, kind of done up. And in graphite in your pencil, they're in sheets, 6-sided sheets. I use that analogy like I don't know if a stop sign's 6 or 8-sided, but they're in sheets. And when you wipe it down, the sheets on top of each other are stacked like stop signs, and they break off and leave this sludge of stop signs that are carbon atoms, one corner, one corner, one corner, one corner, one corner, one corner of carbon atoms, and that would be that's the mark on the paper that graphite leaves behind. So diamond and graphite are both made of carbon, and they're just linked up differently. They're just tied together because they're sharing electrons differently. And we'll get to sharing
why
electrons
is it graphite so
because it's tied together differently.
no, why isn't it so why is it so much cheaper than diamond if it's not so much different?
Because it's so much rarer. Why is aluminum? Aluminum used to be far more valuable than gold. And then they figured out how to refine aluminum or make it. They didn't refine it, but they do electrolysis. And then boom, aluminum became cheap. But aluminum was more expensive than gold because it's rare. What?
Are there any minerals on the periodic table?
Minerals are usually combinations of things. That's like saying when you bake a cake, it's got sugar and flour and things in it, milk and eggs. Those go together. So these periodic elements on the periodic table are like letters. Minerals are like a word. You mix different letters together and you make different words. So I have 26 letters in the English language. How many words?
A lot.
Are you really counting the words?
I'm trying to.
Yeah, don't count the words. Okay. A lot. That's a good answer. There's a lot of words. There's 100 elements. How much stuff is there on Earth?
A lot.
A lot. Good answer. So, that's it. I will shut this one down.